Okay, in this problem, a ball is thrown at an angle of 45 degrees to the ground. If the ball lands 70 meters away, what was the initial speed of the ball? The idea in this problem is to use the equation v naught cosine theta t I plus the quantity h plus v naught sine theta t minus 1/2 the gravitational constant times t squared j. It's a mouthful. Okay. So how do we use this equation, which essentially what this equation does is give us the path that a projectile would take. However, this picture is wrong because you're going to be allowed to assume in these problems, in these examples that I do, you can assume that h is at 0. We know the projectile follows a parabolic path. Not the best parabola I've ever drawn, but it'll work. And like I said, we're going to let the initial height be 0. So that would be our picture that we can kind of refer to in this problem. If we need any insights, x-axis versus y-axis. Okay, we want to find v naught. So let's fill in this equation with what we have as best we can. We know that if we put in 45 degrees for theta, cosine theta, sine theta, same thing, we'll get radical 2 over 2. So let's fill that in. Get v naught radical 2 over 2t times I plus h is 0, theta is 45 degrees, so we'll get plus v naught rad 2 over 2 minus, okay, we're in meters here, and if you're not told otherwise, you can assume that t is in seconds. So the gravitational constant here is going to be 9.8 meters per second. That's the acceleration due to gravity in the metric system. You multiply that by 1/2 and you get minus 4.9 times t squared times j. So we know how far the ball goes horizontally. Because it lands 70 meters away, we're assuming flat ground. So we're assuming that this distance horizontally is 70 meters. Which means we can set the I component equal to 70. So v naught radical 2 divided by 2 times t, set that equal to 70. That's the horizontal distance that the ball travels. Now, obviously we can't solve this equation because it has two unknowns. One equation, two unknowns doesn't work. But we can also do something with the j component because we know the height here is 0. Again, assuming flat ground. We know the height is 0 here. And the j component gives the height. So let's set the j component equal to 0. v naught rad 2 over 2 minus 4.9 t squared equals 0. And we've got ourselves a system of equations. By the way, I should have had a t right here. We've got ourselves a system of equations then. And we can solve it. And in fact, just to make our life a little bit easier, since we know t is not going to equal 0 here, we're not interested in where the projectile is fired from. To make our lives a little bit easier, we can divide out this t right here. 0 divided by t is just 0. And we get v naught radical 2 over 2 minus 4.9 t equals 0. Now let me make some room here. Let me shrink some of this stuff down. So what's the best way to solve that system? Well, I don't know. I'll let you try it different ways, but I'm thinking if I go ahead and solve for t, remember I want v naught. So if I solve for t in the second equation in terms of v naught and then plug into the top equation, I think that'll get me to where I want to go at least. So let's see, if I do that, I can have 4.9 t equals v naught radical 2 over 2. So you can think of it as adding 4.9 t to both sides and then switching it around if you like. and then multiplying by 1 over 4.9. So I get t is equal to v naught times radical 2 over 2 times 1 over 4.9, or 2 times 4.9. Now the idea is I'm going to plug this guy in for t right here. And that'll give me, let's see, what's going to happen here. That's going to give me v naught squared, isn't it? V naught squared. And then, so the radical 2 times this radical 2 will give me 1/2, won't it? 2 over 4, yeah. So 1/2, and then if you want to, you could keep the 4.9, this 4.9 in the denominator right there. And then that's going to equal 70. And then the idea is I'm going to multiply through both sides of this equation by 9.8. That's what 2 times 4.9 is, right? Obviously. And then v naught squared is equal to, if you do that, you should get, let me see, 686. You should get 686. V naught squared equals 686. Take the square root of both sides. And if you take the square root, I'm getting 26.19 when I run it through my calculator. That's an approximation. And that'll be in seconds. Again, if you're not told otherwise, the time units will be in seconds in a problem like this. So that's it. I'm going to take this as my answer.